a second. Okay. So let's look at questions 1 through 12 first. Are there any questions on problems 1 or 2 that y'all want to look at? 1 or 2? So what it wants us to do with these here, it wants us to factor them. So we want to be able to factor, or we're going to factor 9r squared minus 36r minus 45. Now the first thing we look for when factoring is a greatest common factor. In between these three terms, the greatest common factor is 9. So we're going to factor it out. And if we factor 9 out, we're left with r squared minus 4r minus 5. Once we've factored out all the greatest common factors, we'll have our 2 sets of parentheses with 3 spaces. After that, we'll find the sign. And to find the sign, we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. And since it's negative here, they're going to be opposite. One is going to be positive and one is going to be negative. Now that brings us to the next part, the factors of the first and third term. Well, the factors of r squared are r and r. And the factors of 5 are 5 and 1. Now we can just plug them in because the last part is to check. R times negative 1 is negative r. 5 times r is plus 5r, which gives us positive 4r. Is this the middle term we're looking for? Well, no, we want it to be negative. So the easiest thing we can do is switch the signs. Make the 5 negative and the 1 positive. Because if we check it again, 1 times r times 1 is just going to be positive r. Negative 5 times r is negative 5r, which gives us negative 4r, which is what we want. So this here are our factors. Now again, because there was a greatest common factor of 9 that we factored out, it does need to be included in your answer. It is part of it. Any other questions on 1 or 2? Okay. Questions on 3 or 4? One of these that y'all want to look at. 4. 6x squared minus 5x plus 1. Is there a greatest common factor between all 3 terms? Well, no. So we'll rewrite it as 2 sets of parentheses with 3 spaces. The next part is to find the sign. So we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. Well, here the third term is positive, and the sign of the middle term is negative, so both of our signs would be negative. From here, we're going to find the factors of the first and third term. So we're finding the factors of 6x squared. Well, x squared is going to be x and x. Now the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? Okay. Now we also need to find the factors of 1. Well, they are 1 and 1. Those are the only factors of 1. And last but not least, we can check it to make sure we got the correct setup. 2x times negative 1 would be negative 2x. Negative 1 times 3x would be negative 3x, and 2x minus 3x is negative 5x. Is that what we wanted? So these here are the factors. Questions on this here? Any other questions on 3 or 4? Questions on 5 or 6? We can look at 6. So when we look at number 6, is there a greatest common factor between all 3 terms? Well, there's not a whole number, but there is a factor I would pull out, and that would be the negative 1. I would pull the negative out because I don't like having the first term positive or negative. I don't like having the variable, or I don't like having the number in front of the variable that is squared being negative. So here I'd pull it out, which would give us 3t squared minus 11t plus 6. Would it work with leaving the negative in? Yes. But when we find the factors of the first term, we're going to have to include that negative in there. Now that we pulled that out, we would have 2 sets of parentheses with 3 spaces. And we're going to find the sign. So we look at the third term. If the third term's positive, the signs are the same and they match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here it's positive, so they'll be the same and match the sign of the middle term, which is negative. So we have a negative and a negative, or minus and a minus. And this brings us to the factors of the first and third term. Well, the factors of t squared are t and t. And the factors of 3 would be 3 and 1. So I'm just going to put a 3, and then we can leave the other as just t, because 1 times t is the same as just having t. Now the factors of 6, well, it is 1 and 6, or 2 and 3. Which one do we want to try first? 2 and 3. Now the last part is to check it. 3t times negative 3 would be negative 9t. Negative 2 times t would be negative 2t, which gives us negative 11t. Is that what we wanted? Well, yes. So this here would be our answer. We would need to include the negative in there since we factored it out. Any other questions on 5 or 6? Questions on 7 or 8? 8. 8 is one of our special ones. Because we called this the difference of what? Perfect squares. Because 4n squared, is there a number that multiplied by itself that gives us 4n squared? Well, what times itself is 4? What times itself is n squared? N. So 2n times 2n is 4n squared, yes? What times itself is 49? 7. So this here is one of our difference of perfect squares. And there's not a greatest common factor to pull out to get this to work. Because we said what times itself is 4n squared. Well, 2n and then we would have 7 and 7. And we could check it to make sure that it does work. Because 2n times negative 7 would be negative 14n. 7 times 2n is plus 14n, which gives us 0. Because did we have a term with n to the first power? Well, no, we had 4n squared minus 49. There's no middle term, so we should expect it to come out to be 0. And that's it. Any other questions on 7 or 8? Questions on 9 or 10? 10? So we look at this here. Is a squared a perfect square? Is 25b squared a perfect square? So this here again is a difference of perfect squares. So our signs will be opposite. And what times itself was a squared? And a. What times itself is 25b squared? And 5b. Because this is really just going off the perfect square kind of setup in that a squared minus b squared is equal to a plus b times a minus b. Now number 9 would actually be 14x minus 12 times 14x plus 12, because 196 is 14, not 13. Looking at both of these here, is there a greatest common factor between 14 and 12? There should be. What number will go into both 14 and 12? 2, yeah, because they're both divisible by 2. Well, 14 and 12 here is both divisible by 2. So I can pull a 2. I can factor 2 out of both. Because if I factor 2 out of the first set, I'm left with 7x minus 6. If I factor 2 out of the second set, I'm left with 7x plus 6. Because I factored 2 out of the first set, I factored 2 out of the second. Well, 2 times 2 is 4 times 7x minus 6 times 7x plus 6. Now, most likely, if it is a difference of perfect squares, and it works out that we could actually simplify down without factoring out the greatest common factor, but there is one that appears like this here, most likely that greatest common factor will be a perfect square. Because for it to work, it has to be a perfect square. If it is set up in this way, and there's not a setup that works, check to see if there is a greatest common factor, because there might be one that we can pull out which would make it into a difference of perfect squares. Any other questions on 9 or 10? Questions on 11 or 12? 11 and 12 are just going to be the same as what we did at the beginning. It just works out that the sets of parentheses will be the exact same. So for 11, it would be a minus 14 times a minus 14. It's just the same set of parentheses squared. Questions on 13 through 16? Plug it in. Plug it in. So if we plug it in, we'll get 64,160. I mean, it works with any of these here. We just have 2 numbers. So with all of these here, we can plug them into the calculator and have it simplify it for us. We don't have to work these out. Questions on this here? Questions on 17 or 18? One of these that we want to look at. Now this here, so what are the directions for 17 through 23? By any means. Well, what are the different ways that we learned how to solve quadratics? Because the square root method, we also had what? Because there's a few more. That was the first way we went over solving. Completing the square was one, because that was one of the ones we had that works every time. What's another? We had the square root method. We had three other methods to solve. What were they? Factoring. What else? One of them started with a G. Graphing. And the last one was the quadratic formula. So if it's saying that we can solve each of these equations by any means, does it matter which one we use? So graphing worked well if the answers were what? What kind of answers did we look for if we were wanting to graph? Whole numbers, yes? So if it works out that there's whole number solutions, we can graph it. Most likely, if it graphs, it is factorable. And then the square root method worked well is if we did not have a middle term or we had a set of parentheses squared. Completing the square in the quadratic formula worked every single time. So if we're looking at number 18, is there a middle term? Because the middle term would be what? Because what term, or what is the number in front of x to the first power? Do we have an x to the first power? So we don't have a middle term. So we can use the square root method on this here. And the square root method was to get the set of parentheses squared or the variable that is squared by itself. And the first thing we can do is to add 9 to both sides, which tells me that I have x squared is equal to 9. Then we would square root both sides, because the square root of x squared is just x is equal to positive negative 3 or plus or minus 3. And that's it. Could we have graphed this? Well, yes. That would have worked too. We could have actually used any one of these methods and got the answer. Any other questions on 17 or 18? So since it says any method, the first thing we could try is graphing. We can plug it into the graphing calculator, have it graph it, and see, does it give us two answers? The other method we could do is factoring. Now when we look at this here, we look at the third term, because there is no greatest common factor, so we don't factor anything out. But we do have two sets of parentheses with 3 spaces. We'll look at the signs, or find the signs. We'll look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. Well, since it is positive, the signs are the same and they match the sign of the middle term, which is plus. So we have plus and plus. Which brings us to our factors. Well, the factors of the first term are x and x, because those are the only factors that multiply together to give us x squared. And the factors of 2 are 1 and 2. Now off to the side somewhere we can check it to make sure. X times 2 is 2x. 1 times x is plus x. And 2x plus x is 3x. So that tells us that these are the correct factors. Now, according to the square root method, or not square root method, according to our zero product property, any two things multiplied together to equal 0 means one of them must be 0. So we're saying that x plus 1 is equal to 0, or x plus 2 is equal to 0. Now we just need to solve for the value of x. So here we can subtract 1 from both sides, telling me x is equal to -1. Here we can subtract 2 from both sides, telling us x is equal to -2. And those would be our two answers. Any other questions on this here? Any questions on 19 or 20? 19 or 20? 20. Now this one here is interesting because we do have a set of parentheses squared. We can use the square root method on it because we can get that set of parentheses squared by itself and then square root both sides. Well, the first thing we need to do to get it by itself is to subtract 2 from both sides. This 2 and -2 would cancel, leaving us with 4 parentheses. X minus 1 squared is equal to 8. Now the parentheses aren't completely by themselves yet. We need to do what next? Divide both sides by 4. And when we divide both sides by 4, we're left with x minus 1 squared is equal to 2. Bless you. Now, since we have the set of parentheses squared by themselves, we can square root both sides. So the square root and square would cancel out, which would leave us with x minus 1 is equal to plus or minus the square root of 2. Now, since the square root of 2 will not reduce, it will not simplify any further than this without turning it into a decimal. We can leave it as this here. We just have to add 1 to both sides, which tells us x is equal to 1 plus or minus the square root of 2. Any other questions on this here? Any other questions on 19 or 20? Yes. Yes. Now, number 19, we do need to get this equal to 0 because we do have an x squared and an x term. So we'll subtract 2x from both sides to start off with. And what that leaves us with is 1/5 x squared minus 2x plus 6 is equal to 0. Now at this point here, we can plug this into the graphing calculator to see if it will give us the solutions, if it will graph. Because if it graphs and gives us whole number solutions, then we're done. We just have to list those out. Now, most likely, I believe this won't give us whole number solutions. We're actually going to have to use a different method than graphing. The tricky part is the 1/5. That's going to cause a little bit of a challenge. So what we can do is we can actually multiply the whole equation by 5. Now the reason we do this is because of this first multiplication here. Because 5 times 1/5 is what? 1. It's 1. Because it'd be 5 over 5, which reduced to 1, which leaves us with x squared. Now we do have to multiply through the rest of it. 5 times -2x is -2x. plus 30 is equal to 0, because 5 times 0 is 0, 5 times 6 is 30. Now, the reason we did this is just to eliminate that 1/5. We could have left it in there and used completing the square, or really completing the square would have simplified it out, or the quadratic formula would have worked with it just fine. But by multiplying through by that 5, it's going to make it a little bit easier to work with. Now, at this point here, I'm just going to go on and use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now here, what is the value of b? Negative 10, because the number in front of x squared is our a, number in front of x is b, and the number by itself is c. So we're going to plug negative 10 into negative b. Well, the negative and negative would make a positive. Plus or minus square root of negative 10 squared minus 4 times a times c all over 2a. Well, a is 1, so 2 times 1 would give us 2. Now the next part would be to find, or to simplify everything inside the radical. Now again, if it gives us a decimal number, the graphing calculator won't, if the radical won't reduce completely, the graphing calculator will give us a decimal answer. If it comes out that what's inside the radical is negative, the yellow calculator won't solve it at all. So it's easier to just simplify what's inside the radical first. And if we type that in, we should get negative 20. Now the square root of 20 won't reduce completely, so the graphing calculator would give us a decimal answer. Because of the negative, the yellow calculator won't take or simplify the square root of negative 20. But we do know the negative is going to come out as I, which leaves us with the square root of 20. Now the yellow calculator will reduce the square root of 20, won't reduce the square root of negative 20. But we know the negative does come out as I, so we can type the square root of 20 into the yellow calculators, telling us that it is 2 square root of 5. Because 20 is the same as 4 times 5. The square root of 4 is 2. But we cannot take the square root of 5, so it stays inside the radical. Any questions on any of this here? Now, if 10, 2i, and 2, if all three of these have a greatest common factor, we do need to reduce it. Is there a greatest common factor between all three? 2, because 10, 2i, and 2 are all divisible by 2. Well, 10 divided by 2 is plus or minus. Well, 2i divided by 2 is square root of 5. And that would be our answer. Now, because of the imaginary parts, the only two ways that we could actually have solved this is by completing the square or the quadratic formula. Are the only two that would really work for this here because of the imaginary terms. Any other questions on 19? Questions on 21 or 22? 21, yes. Now, since again it's still solving by any method, we could subtract the 8 over and plug it into the graphing calculator to see can we graph it to find the solution. So we could say minus, we could type it into the graphing calculator like this here, 2 parentheses x plus 2 close parentheses squared minus 13, and see, does the graphing calculator give us solutions? If it does, we have our answers and we're done. If it doesn't, we have to go about a different method. the one method I would choose is the square root method, because we do have a set of parentheses squared, and that's the only place where x shows up. So we can get the set of parentheses by themselves first. Now the first thing we're going to do is we're going to add 5 to both sides, because negative 5 plus 5 is 0. So we have 2 parentheses, x plus 2 squared is equal to 13. Now the next step would be to divide both sides by 2. There's negative 2 divided by 2 is 1, leaving us with x plus 2 squared is equal to 13 halves. Now the next step would be to square root both sides. Now over here, the square root and square would cancel, leaving us with x plus 2 is equal to plus or minus the square root of 26 over 2. Now the way we can simplify this, if you want to plug it into the calculator, is the square root of 13 over the square root of 2. The yellow calculators will actually simplify that down, because we don't want to leave a fraction in a radical. Because if we did this by hand, we would multiply the numerator and denominator by the square root of 2. Well, the square root of 2 times the square root of 2 is 2. And the square root of 13 times 2 is the square root of 26. Any questions on this here? Now the last part is that we still need to get x by itself, so we would subtract 2 from both sides, which will tell us x is equal to negative 2 plus or minus the square root of 26 over 2. And I would take that as an answer. The other way that we could write it would be negative 4 plus or minus the square root of 26 all over 2. Because if we wanted it, we would just get 2 to have the same denominator, get them to be the same. I will take either one of those. Any other questions on 21 or 22? Questions on 21 or 22? Questions on 23? Now, if we look at this here, we could try typing it into the graphing calculator and graphing it, getting everything equal to 0. But that's not going to give us a solution. It won't cross the x-axis. Now, there is something interesting with our y squared minus 24y plus 144, in that it is a perfect square trinomial. It is one of our perfect square trinomials. It will factor. And it actually works out to be y minus 12 squared. Because y minus 12 times y minus 12 actually gives us y squared minus 24y plus 144. Any questions on how we got to this point? Well, at this point here, we can square root both sides. Here, the square root and square would cancel, leaving us with y minus 12 is equal to plus or minus. The square root of 100 is 10, and the negative comes out as 9. Then we can add 12 to both sides, which tells us y is equal to 12 plus or minus 9. Because we could have solved it this way here. We could have moved the 100 over and used the quadratic formula and gotten the same thing. Any questions on number 23? Questions on 24 or 25? 25, yes. So here, we want to solve each of the equations by using, solve each equation by using the completing the square method. So there are going to be a few of these on the test where it specifically asks for a specific method for you to solve. So here we're going to be asked to use the square root method, or sorry, completing the square. So you need to solve it by using the completing the square method. Now if on the test for some reason you blank on how to do completing the square, you still need to solve it. Because if you can solve it by using a different method, do that. Because at least if you can get the correct answers, you'll get the points for doing the work, for getting the correct answers. You'll just lose a point or two for not doing it by the specified method. I'd prefer that you get the correct answers by a method it didn't ask for than to not do it at all. Now, when we look at number 25, we have 5x squared plus 30x is equal to negative 50. Well, the second step in completing the square is to get the variables on one side and the constant terms on the other. Is it already there? Are the variables on one side and the constant term on the other? Well, yes. So I'm not going to do anything with the negative 50. If we were using the quadratic formula, then I would need this equal to 0. Now, the first step in completing the square is a equal to 1? If not, make it so. So we need to divide everything by 5. Because when we divide everything by 5, well, 5x squared divided by 5 is 30 divided by 5 is plus blank is equal to 10 plus blank. Now we can go on and add that because, again, we need to find the value of c, and since the constant term is already by itself, we don't need to move anything. Now again, c is b over 2 squared. And the problem we have here, the value of b is, now 6 divided by 2 is, and 3 squared is 9. So we have 9 and 9. So that takes care of the first 3 steps because we got a equal to 1. We found the factors. We moved the constant terms over to one side and have the variables on the other. The third step was finding the value of c, which is our b over 2 squared, which turned out to be 9. Now our next step is to factor this to a set of parentheses squared. And again, the number that goes inside the parentheses will always be whatever the number we got before we squared it when finding c. So here would be plus 3. Now negative 10 plus 9 is negative 1. Well, our next step would be to square root both sides. Now the square root and the square would cancel, leaving us with x plus 3 is equal to plus or minus what? I, 1i, or I. Because the square root of negative 1 by definition is I. Now at this point here, we still need to get x by itself, so we would subtract 3 from both sides, telling us that x is equal to negative 3 plus or minus I. Any questions on any of this here? Any other questions on 24 or 25? Okay. Let's look at 26 and 27. Is there one of these in particular that you all want to look at? Let's look at 27. Now for either one of these here, we do need the equation equal to 0. So for 27, we do need to move the 4x squared over, so we can add it to both sides. And if we add 4x squared to both sides, we're left with 4x squared minus 7x plus 6 is equal to 0. Now this one here asks for us to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. AC. Now what we're going to do is plug in the values of a, b, and c. Well, the value of b is, it's negative 7. So if I plug it in for negative b, it would just be 7. Now inside the set of parentheses, inside the square root, we would have negative 7 squared minus 4. Well, a is 4 and c is 6. If it's all over 2a, well, the value of a is 4, so 2 times 4 is 8. Now again, at this point here, we would simplify everything inside the square root. So 7 squared minus 4 times 4 times 6. I think it should be 47. Yep. Because if we type in negative 7 in parentheses squared minus 4 times 4 times 6, it should work out to be negative 47. Let's finish this out here because we're almost done. Well, 7 plus or minus. The only way that we can simplify the square root of negative 47 is pulling out the I. And that right there is our solution. We will finish this tomorrow, and your test will be Wednesday and Thursday.